Comet built Opik to enable developers like myself to build best-in-class LLM applications. And Opik's popularity has really been taking off, and it's going a bit viral right now. This is all due to the ease of integration and to how critical both observability and optimization are to building LLM apps. Our repo on GitHub recently hit 10K stars. And Opik's popularity has really been taking off recently. It's actually going a bit viral. And this is all due to the ease of integration and to how critical both observability and optimization are when building LLM apps. Our GitHub repo recently hit 10K stars. As an open source project, Opik provides its full LLM evaluation feature set for free, ensuring accessibility for teams of all sizes. The Opik traces that you're seeing here help you easily log, visualize, and evaluate everything from raw LLM calls to advanced RAG pipelines or complex agentic systems through a robust set of integrations with popular frameworks and tools. This tabular view includes all the expected features such as adding columns and removing them. So you have a lot of control over the view that you're seeing for your project, and you can also expand this row view to get the ideal side-by-side comparison of each call through your LLM system. This is a RAG example where I have a retrieval step. This project is a chat with your docs RAG system where I can ask questions of the Opik documentation and the LLM will return a response. So there's a few simple steps here, but you can see how important it is to log each step so I could get visibility into exactly where my chain might be breaking. What we're looking at here is a single trace, and within the trace is a few spans. You see a span for retrieving the docs, and that's where we see the RAG step where relevant documentation to the query is retrieved. And the really cool thing about this is I can see the exact information that was retrieved. So if I'm building a RAG system and I'm worried that maybe my retrieval step isn't working, I can inspect the retrieval step individually across multiple calls through my LLM system. And it's going to give me great visibility into how I might fix my retrieval step. I also have the chat completion call. So this is the call to the actual LLM itself. This is a call out to OpenAI. And again, you see the inputs and the outputs, really fantastic way to visualize every step in your LLM system. Now, I want to show you how truly easy it is to integrate Opik with your existing code if you're building an LLM app and automatically log your traces to Opik. This example, I'm using OpenAI, so you can see I'm importing two libraries. I have Opik and OpenAI. And the first thing I'm doing is naming my project. This is the project name that's going to show up in the UI and really tell Opik where we're logging these traces to. Then all I have to do, because I'm using Opik's OpenAI integration, is simply instantiate this client here. Then I'm using the Opik track decorator to track each step in my function. Opik is going to automatically log calls from OpenAI SDK like this one. And in addition to logging that call, I want to also log these different steps because I've built more of a complex system here that's not just one step. I have a retrieve context step, and I also have an entire generated response and LLM chain. So by using this track decorator, I am defining exactly what I want these traces and spans to look like and how I want them to be logged to the UI. And this is not just for OpenAI. Opik offers many automatic integrations, just like the one I just showed you, for almost every tool that you could be building LLM apps with. So I encourage you to check out this page here if you're looking for your own tool. And you'll also find code examples for a lot of these popular tools that will help you jumpstart getting your traces logged. Now, back in the Opik UI, we're moving into some of the most powerful features Opik has to offer. Now that we've logged our traces, the next step is to think about how are we going to actually evaluate our traces, and that's where evaluation metrics come in. Evaluation in Opik helps you assess and measure the quality of your LLM outputs across different dimensions. It provides a framework to systematically test your prompts and models against datasets using various metrics to measure performance. But we all know LLMs are language models, and the inputs and outputs are text data, and you could even be working with other forms of Gen AI, such as video and audio. Evaluating these kinds of data sources is incredibly challenging. So how do we do it? We also know that these kinds of models have very common behaviors, such as hallucinations, fairness and bias issues, misuse. There's many things that we really want to measure and detect, but actually putting a real metric on that and measuring these kinds of quality issues in LLMs is quite challenging. So the approach is to use an eval metric. I have a few examples here. The first is for hallucination. And the way I'm measuring hallucination is I am getting a score, so it's a binary output, 0 to 1, whether it's hallucinating or not. And this hallucination can be used to score every single trace that goes through my system. But how do I actually get a metric to measure this? This is something called LLM as a judge, and I'm going to hop in to show you how to create these kinds of metrics. So you can see here I have a hallucination metric. Let's go ahead and edit it, and I'll show you how this metric is actually created. This metric is an LLM as a judge metric. I am using another LLM to judge the output of my first LLM. It's essentially a prompt because it's really just another call to an LLM. But the amazing thing about this being a prompt is two things. Now that I already have my traces logged, I know the schema of the traces, so that helps me really define a prompt on top of the schema of the traces very easily. The other thing that's really fascinating about this metric actually just being a prompt is it's completely customizable. And I have seen people using Opik to make some of the most customized and powerful metrics I could dream of. Using LLM as a judge within Opik, I am able to really use language to direct exactly what I want to measure that could go wrong or right in my systems. And because I'm forcing the output to a binary output or any kind of numerical value, I now have an actual number that I can trace and monitor in a dashboard. Now, Opik provides the following built-in evaluation metrics. You can see here there's two categories. There's heuristic as well as LLM as a judge. The heuristic metrics are going to test for simple things that are very key for specific kinds of systems, such as generating JSON. You always want to do a check just to make sure that the output is indeed following specific JSON format. So that's a great example of what a heuristic metric might be. Scrolling down here, you can see that I have a ton of LLM as a judge metrics pre-built and available to me, including geval, which is personally my favorite because this is one that allows me to just create any custom evaluation metric that I want. But let's click into the hallucination one to show you an example of what it looks like to define the metric through code. I showed you how to set it up in the UI, but everything I showed in the UI can also be done programmatically. So here I am defining the metric itself, and it really is just a prompt. That hallucination prompt that we saw in the UI can be written programmatically and implemented through code, again with just a few lines of Python code. So this code could be layered into your serving layer or wherever it feels most appropriate to run that evaluation. Not necessarily has to be defined in the UI. Okay, so I've logged my traces and I've defined my evaluation metrics. Now let's move into experiments. Now that I've have the traces logged and my experiment metrics defined as eval metrics, it becomes very easy to run proper experiments. Let's say, for example, that I am maybe testing different prompts, comparing different model versions, and trying to track the improvements or issues. Imagine as you're building, you're going to need a way to scientifically compare these changes and measure the improvements. Well, now that we have our traces and eval metrics defined, that becomes quite easy. All we need to do is upload a baseline data set and run the comparison side by side over the data set. So here, I've been iterating over my prompt, and I can run a side-by-side comparison. And because I've already defined that the hallucination metric is what I'm concerned about and looking to optimize as I change my prompt, I have an actual numeric metric from this LLM as a judge metric that I can use to measure the improvements of my experiment. And then scrolling down here, I can easily compare the changes in the inputs and outputs for each run. And again, setting this in a way that is most visually pleasing for whatever kind of data I'm looking at. I can also store and version my prompts to maintain consistency and simplify experimentation across projects. Using a prompt library does not mean you can't store your prompt in code, because we have designed the prompt library to work seamlessly with your existing prompt files while providing the benefits of a central prompts library. My recommended way to create and manage prompts is using the prompt object. This will allow you to continue versioning your prompts in code while also getting the benefits of having prompt versioning managed in the Opik platform so you can more easily keep track of your progress. And when working with developing LLMs, there might be a time when you really want to quickly try out different prompts and just see how they perform. Opik's Prompt Playground is a perfect way to do just that. Now, last but not least, I'm going to wrap up with another powerful tool to assist you in prompt engineering and in optimizing your agents overall, the Opik Agent Optimizer. In Opik, the Agent Optimizer refers to the systematic process of refining and evaluating prompts, configurations, and overall design of language model-based applications to maximize their performance. And it does this in an autonomous way. And it does this in an automated way. This is an iterative approach leveraging continuous testing, data-driven refinement, and advanced evaluation techniques. Prompt optimization is a crucial subset of agent optimization since prompts are the primary way to interact and guide your LLMs. Optimizing them is really then fundamental to enhancing any LLM-powered agent or application. And the Opik Agent Optimizer provides tools for both, directly optimizing individual prompt strings and also for optimizing more complex agentic structures that might involve multiple shots, few shot examples, or tool interaction. To use the Agent Optimizer, you simply need to define an evaluation dataset, configure your evaluation metric, and define a base prompt as your starting point. Then you choose and configure the optimizer algorithm, and then simply run the optimization. After the optimization completes, you'll see a summary of the optimization, including the best prompt found and its score based on the evaluation metric, and this is going to be directly displayed in your terminal. In addition to the CLI output, your optimization results are also going to be available in the Opik Agent Optimization dashboard for further analysis and visualization. Thank you so much for taking the time with me to walk through all the amazing features available in Comet Opik. If you'd like to get started with Comet Opik, go ahead and scan the QR code or click a link down below and you can get started using it for free. Bye.